So this time, we're going to talk about salts, and in particular to predict whether dissolving a salt will produce a solution that is acidic, basic, or neutral. And then we'll talk about how to calculate the pH of such a solution. So remember, a salt is really just a chemistry word for an ionic compound. So there's going to be some cation and some anion. And when those dissolve in water, so we're imagining putting the salt into pure water and the ions separate, we then think about how are those ions going to affect the pH of the solution? How are they going to react with water to produce OH- or H3O+. And so here's a rundown of the kind of different possibilities here. So if one of the ions is the cation of a strong base, so you've memorized your strong bases, you know that the cations would be things like potassium and sodium or strontium. Those ions will have no effect on the pH. The solution will remain neutral because those ions can't react with water to produce H3O+. Similarly, if we think about the anions of a strong acid, you memorized your strong acids, so you know that these are ions like chloride or bromide or nitrate. We know that those ions, that the strong acid will be completely dissociated, so those ions will not react with water to produce OH-, and so once again they'll have no effect on the pH of the solution. If we think about the conjugates of weak acids, on the other hand, so the conjugate base of a weak acid is itself a weak base. And if you put a weak base into solution, the solution will become basic. So the conjugate base of a weak acid will make the solution basic. In the same way, the conjugate acid of a weak base, so if your cation is the conjugate acid of some weak base, that's a weak acid, so it will make an acidic solution. We'll also talk about the way that a hydrated metal, usually transition metal cation, can make the solution acidic as well. So let's do an example. Do you expect a solution of ammonium chloride to be acidic, basic, or neutral? We expect this solution to be acidic. Let's talk about that. So ammonium chloride, when you put it in water, is going to dissociate into ammonium cation and chloride anion. And I recognize these because ammonium is one of my polyatomic ions that I memorized, and what's left over is chloride. So then I can think about how these are going to impact the pH of the solution. NH4+ I should recognize as being the conjugate acid of NH3, ammonia, a weak base. This is the conjugate acid of a weak base. It has an extra proton and a positive charge. So this is going to react with water to lose a proton, to donate a proton, which makes it an acid. That's going to produce H3O+. And now if I balance this reaction to see what's left, I end up with ammonia. So the ammonium cation produces H3O+, which is going to make the solution that this is in more acidic. If I do the same logic with HCl, if that were going to react with water, I would expect to make HCl and OH-. Now, this reaction doesn't actually happen because HCl totally dissociates to produce Cl-. So this reaction lies all the way toward the side that has chloride. Therefore, the chloride ion has a neutral or no effect on the pH of the solution. So if we said that the ammonium cation was acidic and the chloride ion has no effect, together those make for an acidic solution if we dissolve ammonium chloride in water. Okay, what about sodium chloride? So sodium chloride, on the other hand, we would expect to produce a neutral solution. And so let's think about that. We have sodium chloride, which we will know will dissociate into sodium ion and chloride ion. The sodium cation is the conjugate acid of sodium chloride or sodium hydroxide. So we might expect it to react with water to make sodium hydroxide and H3O+. However, we know that this reaction doesn't happen because sodium hydroxide completely dissociates to form sodium ion. So this equilibrium lies so far toward the reactants that we consider that the reaction doesn't happen. Therefore, we're not going to get any extra H3O plus from solution, and so this ion will have no effect or be neutral on the pH of the solution. Similarly, like we did before, we said that chloride doesn't become HCl and OH minus, so therefore nothing happens. This also has no effect on the pH of the solution. And so if you dissolve sodium chloride in neutral water, which is kind of the underlying assumption here, then the solution remains neutral. So hydrated metal cations. When we dissolve a transition metal, or in this case aluminum, in water, the water molecules interact with the aluminum. They sort of surround it, and about 6 water molecules is about the number that will fit. We'll talk more about how this is actually a Lewis acid-base interaction. But what's important for us here is that the presence of the metal ion polarizes the OH bond. So remember, the aluminum has a charge of 3+, so that is drawing that positive charge draws the electron density from the oxygen. And oxygen is more electronegative than hydrogen, so oxygen draws electron density toward itself, which weakens this OH bond. So the OH bond gets weaker and can dissociate to form aluminum, now with 5 waters and an OH. And so basically this water molecule picks up the proton and attaches to it, making H3O+, and then one of the water molecules that was attached to aluminum is now OH-. So in this way, a metal ion in water makes the solution acidic. Okay, one more practice. Which of these will produce an acidic solution? Let's think about each of these in turn. We said that sodium chloride, because it's going to produce sodium ion and chloride ion, and that both of these are the cation and anion for strong bases and acids, that this solution is going to be neutral. So for lithium perchlorate, that's going to make, lithium hypochlorite, that's going to be lithium and hypochlorite. So lithium is going to be the cation from lithium hydroxide. That's a strong base, so this is neutral. Hypochlorite, on the other hand, so hypochlorite is not one of the anions from a strong acid, so that must mean that it can be a weak base. So hypochlorite can react with water to make sodium hypochlorite, hypochlorous acid and OH-, and so that's going to make this solution basic. Strontium bromide, so some more exotic ions here. Now, strontium is also a neutral ion because it is the conjugate of a strong base, strontium hydroxide, and bromide is neutral because it is the conjugate base of the strong acid HBr. Finally, we have copper nitrate. Now, copper is copper is a metal cation, but it's not one of the conjugate acids of the strong bases. So instead, this is going to form the hydrated metal cation, where we have 6 waters that surround the copper ion, and so that's going to make the solution acidic. The nitrate part, on the other hand, nitrate is the conjugate base of a strong acid, so it's going to make the solution neutral. So the best answer here is copper nitrate.